Okay, Assalamualaikum warahmatullahi wabarakatuh. So let's continue on the peak inverse voltage for your full wave rectifier. So as we recall before, what is a PIV? So your PIV is the peak value where the diode can withstand before damage when it is at reverse bias. So let's say this is your IV characteristics. So at your reverse bias, there is some limit of the voltage before it starts to damage. So this is the limit that what we call PIV. Okay, so now let's derive the PIV. The first one we call center tap. So remember the step of your PIV, first we need to make it at reverse bias, right? So in your full wave, we have both cycle heavy reverse bias. So let's say we have here minus plus means we put at negative cycle. So this is at negative cycle, you put minus plus. So which diode will be off? So this diode will be off, this diode will be on. So diode 1 will be off. So the one at diode that is off, where it will be open circuit. So means here is open circuit and you having PIV here. So you and then you need to put the sign, here become minus, here become plus. Okay, and then you have the KVL at your PIV. So what is the KVL at your PIV? Is this loop. So what will be the equation at this loop? Means here become VS minus PIV plus V out equal to 0. So you can get your PIV is actually VS plus V out. Equation number 1. But in this equation, you have what we call V out here. So how you can derive for your V out? So remember just now you have the diode that is on here. So that's where your V out comes from. So you need to have the KVL at the diode that is on. So it will be here going up until here. So let's start at the diode. So D2 will be on. So you are going to replace with V gamma. Going up, it will go to your V out. And then go through the Vs equal to 0. So you can get here V out equal Vs minus V gamma, equation number 2. Replace equation 2 into 1, so you can get your final PIV equal Vs plus Vs minus V gamma equal to 2 Vs minus V gamma. So this is the equation for your PIV for what we call center tap transformer. Okay, so let's move to the full bridge. So this is what we call full bridge. Okay, as usual, you're going to start at the negative cycle. So here become minus and plus. So this is step number 1. Step number 2, find out which diode is off. So here minus, so you become minus. Here is plus and plus. So look at here which diode will be off. So the diode that will be off is diode 1 and diode 2. So diode 1 and diode 2 will be off. The one where the diode are off, where you put your PIV. So you have two PIV here. One is at D1, one is at D2. And then don't forget the sign, here become minus, here is plus, and here is plus, and here is minus. So now let's draw the KVL equation through the PIV. So you go through here, going to the PIV, go to the V out, PIV again, and then to the plus. So what will be the equation for your PIV? So starting from here, let's say you become KVL says VS, go to the PIV, means you beat the minus first, minus PIV. Go to the R, you beat the plus first, V up. Go through again, the PIV is become minus PIV again, equal to 0. And then here you can get 2 PIV equal Vs plus V0. So means your PIV equal Vs plus V0 divided by 2. So this will be equation number 1. So equation number 2, where you're going to derive the value of your V out. So in order to derive the value of your V out, you need to check which diode is on. So means diode 3 and diode 4 is on, right? So let's draw the KVL at the diode 3 and diode 4. So here we will start from plus Vs. So plus Vs, go to the diode 4. So it become plus V gamma. It go like this. Diode 4, go to the V out plus V out. And then you have V gamma again towards the end. So it become V out plus V gamma again equal to 0. So you have here V out equal V. Okay, sorry, this is minus because you're starting from here, right? So minus Vs plus V gamma plus V out plus V gamma equal to 0. So you can get your V out equal to Vs minus 2V gamma. Okay, so this will be equation number 2. So you need to replace 2 inside 1. So how are you going to put that? So it means here is PIV equal to Vs plus Vs minus 2V gamma divided by 2, right? So you can get here means Vs minus V gamma. So for your full bridge, your PIV equal Vs minus V gamma. For your center tap, your PIV is equal to Vs minus V gamma. So this is the voltage where is the maximum voltage before the diode start to damage. This is the maximum voltage that you can put at the diode before it start to damage. Okay, so let's continue. So this is the summary of your PIV. So if you have half wave, you have Vs peak. For full wave, 2 Vs minus V gamma, and full bridge is Vs minus V gamma as derivation that we have done just now. But please don't remember this one. Always go through the steps. Step number 1, always make it at reverse bias. Reverse bias means the diode is open circuit, and you're going to put your PIV at the diode, and don't forget the sign, either plus or minus, and then do the KVL. Because in order for this to do that, it will depend on the question. If the question say PLM1, you're going to replace your diode with V gamma, right? But if you're using PLM2, it's not only V gamma, you're going to replace it with V gamma and RF. So you don't need to remember this equation. As long as you go through this loop of derivation, you can get the correct answer. Okay. So for the last part, okay, if the question given you VRMS, so always change before you start to calculate, always change it to your V peak. So means what is your V peak equal VRMS square root 2. So you need to remember this formula. Okay. So this will be the example of both comparison between your center tap and your full bridge. So you are given RMS. So step number 1, always change it to V peak, means you are going to have here 220 square root 2. Square root 2. Okay. And you're given V gamma here is equal 0.6 volt. Your V out is equal to 9 volt. So what you need to do here, you need to find the N1, N2, and your PIV for both circuits. So we'll see how to calculate this.